To what we were doing yesterday, but I felt like yesterday I was giving a lot more of the explanation of why, and so I just really wanted to clarify what do I actually expect to see on these problems, because I showed you multiple approaches, I showed you by hand and on the calculator, so I wanted to kind of clarify what it is I need to see from you guys. So this first one, if you started your homework, it's like the first question on your homework for tonight. Using both the classical and p-value approach. So this is going to be the only time I ever ask for both. So I will not do that on test or quiz. But I talked about both yesterday, so I wanted to look at both in a problem. We're going to test this hypothesis. Now, no matter what, you always have to check your criteria. Pretty much never will we be able to verify that the sample is less than 5% of the total population. Here we definitely can. I didn't even tell you the population or where this came from. So really what I'm looking for, do you check your n times p times 1 minus p and make sure that's greater than 10. So if you did that on a test, I would give you the point. So n is 300, our p is 0.3, 1 minus 0.3. And you just have to verify that that's bigger than 10.
It's like a freaking pond out there.
It's been a long time since we've had this much rain.
Yeah, and Tamara's wearing like Crocs. Pond was probably running over her shoes.
Very wet outside.
Yeah. Yeah, it looks comfy.
Just lovely out there.
Are freezing. Feet wet or something?
I stepped through a big puddle and then kicked it on Anna.
Okay, you want to? All right, so back to this. If I were going to do this, we have to get a z-score, which means we need our mean and standard deviation. So our mean is just our p. Our standard deviation is our square root of p times 1 minus p over n. And what did I get? 0.0265. All right, so if I were going to do this by the classical approach, I have to get my z-score. So our z is our value, which I guess I need, don't I? What's our p hat?
75 over 300.
And what's that turn into?
125.
So our value minus the mean, 0.3, divided by the standard deviation, 0.0265. So if I do that, we get negative 1.89. Now this one did give us an alpha value. The one we talked about in class did not, so that's why we use the 2 standard deviations. If we have alpha, we don't really have to guess. So if we're talking about the 0.02 low, okay, so that's 2%. We are testing less than, so that means I could only have 2% less than. Okay. So that area is 0.02. Find the z that corresponds to it. So if I look on my normal table, if my area is 0.02, so inside the table, we're looking as close as we can get to 0.02.
Negative 2.88.
I thought negative 2.05.
Negative? Yeah, negative 2. Oh, we're looking.
Oh,
Okay. Classical approach says if you're in this shaded area, you reject. Would negative 1.89 be in the shaded area? No. Remember, this is 0, so negative 1.89 would be over here. That's not in the shaded area, so we fail to reject. That's classical approach. Only that first question on the homework, that's the only place I ask you to even do classical approach. The p-value approach is more straightforward. We're just finding our probability and comparing it to alpha. So we just need to find the probability. We already have our z, so z being less than negative 1.89. Less than is from the table. If you look up negative 1.89, what do we get?
0.02.
That number is bigger than alpha, so we fail to reject. You only reject if it's smaller than alpha. So that's the two different ways you can choose to do the problem. Does that make a little more sense? The next three, I really just want you to practice using our calculators and how we go through it. Even if you're using your calculator, there are some stuff that I want you to write down. So if I look at this one, the drug Lipitor is meant to reduce cholesterol. In clinical trials, 19 out of 863 patients taking 10 milligrams of Lipitor daily complained of flu-like symptoms. Suppose that 1.9% of patients taking competing drugs complain of flu-like symptoms. Is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms as a side effect at the alpha equals 0.01 level? All right, what is my null hypothesis? It's always p equals the 1.9%, so 0.019. What alternative am I trying to test?
Just p is greater than? No. Oh.
Even if you're doing your calculator, you have to write down your hypothesis. You also need to check your criteria. What's my n?
86.
My p is the 0.019. And that gives me 16, which is bigger than 10. So my criteria is good. Then, what did we do on our calculator? Stat test number 5. Okay, on that, the p sub 0 is my x. X is 19. My n is 863. My alternative, I'm testing greater than and calculate. All right, yesterday when I had you do this, we talked about the z value. So it's about 0.65. And then I had you looking at the table just to kind of make the connection that this is the same z that we've been doing by hand and we're getting the probabilities from your table. However, your calculator does give you those probabilities as well. If you look, it has z, p, p hat, n. P is the probability. What's my probability on that one? So if you looked up from the table, it wouldn't match exactly because the table does round our z to 2 decimal places. Your calculator gives z to more places than that, so the probability isn't 100% match, but it is very close to the table. If we looked at our table for 0.65, you have 0.7422, and you'd have to do 1 minus that. So it would come out to be very similar. This is your probability. So what I need to see from you on the test, or on any assignment if you're doing the calculator, you have to show me criteria, your null and alternative. At the very least, write down your z and your p. Okay? On a test, it may not be a bad idea to write down the numbers you're plugging in as well. Then you need to tell me your conclusion. The conclusion is as simple as reject or fail to reject. what would we do here?
Failed.
Right. My P is greater than alpha, so we fail to reject. That's all I need for the conclusion. Now, every now and then, not on every problem, but sometimes I will ask you to explain. If I ask you to explain, that means write me a sentence, explain what that means. So you would say, there is not enough evidence to conclude Lipitor causes more side effects. So in general, conclusion is just reject or fail to reject. If I say explain it, that means put it in the context of the problem. Tell me a sentence. What's it mean? Is that okay? Let's look at number 3. I did change one number after I printed yours. That in yours it says 54, change it to 44. In an American Animal Hospital Association survey, 37% of respondents stated that they talked to their pets on the telephone. A vet found this hard to believe, so he randomly selected 150 pet owners and found 44 spoke to their pet on the telephone. Does the vet have a right to be skeptical? Use alpha equals 0.05. So what's my null hypothesis?
P is 0.37.
Okay, what's my alternative?
P is not equal.
Yeah, this is probably, could have been phrased a little bit better. If he didn't really believe that this was true, I think that would be because he thought it should be lower, but I probably should have stated that better in the problem. So I was really looking at less than 0.37, but I should probably make that more clear in the problem. Criteria. What's my N? What's my P? 1 minus P. And that gives me 34.965, so that's greater than 10, I'm good. So now, you can go to your stat, test number 5. My P is 0.37. My X is what?
44.
And it's 150. Okay. I'm testing less than. So the Z, say 1.94, or P is 0.0259. So what's my conclusion? My P, the probability is less than alpha, so we reject the null hypothesis. If I ask you to explain, that means there is evidence the proportion of pet owners talk to their pet on the phone is less than 0.37. So, do you guys understand what I'm expecting you to show on these problems when I'm asking you to test it using the P code?
So if it's less than the P or the alpha, we would reject the null. And if it's more than the alpha, we would
Fail to reject. It didn't mean the null was true, it just means we didn't prove it false.
Is there times where it could be like turned around, like where you would Or is it always gonna be pretty similar?
Always be the same, yeah.
And we will almost always have an alpha. I thought there was
Yeah.
one that we didn't have.
There was one, the very first one yesterday, I didn't give you an alpha, but I will on all of these. Alright. Last one here. According to an online site, 22% of men have an active sports betting account. A survey of 500 men found that 122 had an active sports betting account. Construct a 95% confidence interval to assess the accuracy of the online site. What's my null hypothesis? What would my alternative be? Yeah. Okay, check your criteria. My N, 500, is 0.22, times 1 minus 0.22. It's 85.8, so that's greater than 10, we are good. So, stat test number 5. P of my null is 0.22. What's X?
122.
So my Z is 1.296. Oh wait, that's not even what I want to do though, is it? What did I ask you to do on this one?
Oh, stat test A.
Yeah, I asked for the confidence interval. Okay. So stat test, letter A. We don't have to put in the P hat. We just have to do the X, the N, and our confidence level is 0.95. Okay, so here's my confidence interval. I am 95% sure the correct answer lies in that interval. So would I reject or fail to reject?
Yeah.
Since 0.22 is in the interval, fail to reject. There's not enough evidence to conclude that the site is inaccurate. All right. Any questions on those? Then I want to flip over to our notes and do the last sample on here. So every time we're checking our criteria and making sure that N times P times 1 minus P is greater than 10. But what if it's not? We check that to make sure that it is normal. So if it fails that requirement, it means it's not normal. If it's not normal, we can't use the Z's and the normal table. What we have to use instead is the binomial approach. It's been a while. We talked about binomial back in chapter 6, like when we were doing our probabilities. Remember, we did normal for continuous data, binomial was discrete data, like countable, and we were reading probabilities from that binomial table. So let's take a look at one. In 2006, 10.5% of all live births in the United States were to mothers under 20 years of age. A sociologist claims that births to mothers under 20 years of age is decreasing. She conducts a simple random sample of 34 births and finds 3 of them were to mothers under 20 years of age. test the claim at the alpha equals 0.01 level. So first, we need our null and alternative hypothesis. What's my null? P equals 105. What's my alternative? Less than. We do our criteria. What's my n? P 0.105, 1 minus 0.105. So if I do that, that gives me 3.19.
That's not.
That is not greater than 10. That's less than 10. So that means this is not normal. That means we can't do what we have been doing. We need to find the probability. She found that 3 of them, so that x is less than or equal to 3. Since it's not normal, we will use the binomial approach. Now here's the downside to that. If you look in your formula sheet, we have the binomial table. Started on like A3, looked like this. Remember we had these probabilities at the top, but the downside of this, did it have every possible probability? No. I need 0.105. I can use this table to approximate, but the best I'm going to do is 0.1, right? And so then remember we also had to have x and n. How many, or what was our n on this case? 34. What's the highest our table went to? 20. So we would have to have a much better table to get that. So we can do this on our calculator. I just didn't show you that before because I wanted to use the table. So on our calculators, so you're going to hit second, that bars button, which is by the clear, and then you want, I don't remember the number. Okay, I want to do letter B, which is binomial CDF. There's 2 different binomials. A lets you do one at a time, so you'd have to do it for 0, 1, 2, and 3. Option B actually lets us get everything at once. It does a cumulative probability. So if I say I want to go up to 3, it adds everything less than that. So how many trials?
33.
Okay, what is my P? What is my X? That's the 3. If you hit enter, it actually gives it to us. So 0.5149. Yeah. Now, I'm not going to make you do this often, like on a homework, but the majority of what we're looking at is going to be the ones that we can use our normal distribution for. So, would I reject or fail to reject?
Failed.
That's greater than alpha. So fail to reject. All right. Any questions?
Did you do 0.15, not 0.105?
Oh, hit enter.
I laughed, but not this. Where is it? Look what the treats were.
Oh,
grave. I'm not messing with this, it smells like grave.
We're doing,
We're doing breakfast tomorrow morning.
we're doing breakfast tomorrow morning. Or we're doing a meal tonight.
Yeah, Toby's mom's making like 60 graves.
Oh, my mom bought, I think she's making, my mom made like eggs.
That's her answer.
Where's that?
8:30 a.m. sharp,
Okay,
which is good.
you have the
Because
rest of
need
the
to be
time
out
to work
there
on your homework.
before that.
Do Monday?